So what are we looking at?
So we have 100% polyester fabrics here, all used and discarded. So doesn't say exactly which grade of plastic, but this is 100% polyester. So we're trying to see if this can be pyrolized in the blessed machine that we have.
What else we got?
Instead of burning it in an incinerator, the process that we're using here doesn't use any oxygen. So this is also again 100% polyester. I will try to see if we can find some blends of synthetic fabrics that we can add to the mix and maybe get a different thought. So we have polyester and spandex here. Spandex is what makes this stretchable. So this back panel essentially is all that has spandex.
Okay.
So this will probably also produce some jar. Cotton.
So this is a project about finding different ways to use textile waste.
This is a project about trying to find solutions for diverting textile waste from landfills. And this does not say. Sorry.
But at the end of the day, you don't want to spend a lot of time sorting because that would increase cost, a huge labor cost.
Right, this is 100% cotton, so not adding this. If we have any kind of blends, those can probably go in the same pile.
So 100% compost could go in, 100% cotton could go in the compost,
Yes,
as
100%
Erica has demonstrated.
cotton can go into the compost. The worms will probably decompose it within 40 days. So this is 100% polyester.
Okay.
Another part of the solution is to shred all the textile waste. This is a solution that's very effective, that's been tried and tested and replicated in several countries, included in the United States, part of Europe. There's a company called Baux in Stockholm that uses 100% traceable textile waste to make insulation panels
From the shreds.
from shredded polyester and cotton fabrics. They also use PET and waste wood. So the last thing that we have, just quickly going to check the label. So this is rayon. Now rayon is 100% rayon. So rayon is like a natural fabric, so we won't have this.
Rayon's a natural fabric?
I think it's some part of the plant. I'm not sure. Viscose and rayon are not synthetic. So I'll have to look this up. I'm not sure.
Okay. But you want to go with this batch here?
Yes, this is all 100% polyester. 3 garments discarded, all 300% polyester. So.
And what did we have coming out of the machine?
We have plastic that we tried to experiment with last week, and this is the result of it. This was at a little over 250 degrees
Fahrenheit.
Fahrenheit.
Right, so just the thermoplastic that milk jug and that plastic bag just melted as they would. It's like cookie sheet temperature, and that's what you use for reforming thermoplastics without turning them into gases, off-gassing, or not much off-gassing at that low temperature. That you can do in an oven on a cookie sheet and then reform those plastics. This machine gets up to 760, 780 degrees Fahrenheit with a filter here at 662 to turn it into carbon dioxide and water, so there's no off-gassing. The plastic turns into oil here, and that all happens at those prodigious temperatures there, which is not what we did here. We stopped the reaction before it got to even 300 degrees Fahrenheit, and then pulled the stuff out. But that was to drive off the air and the water. So I'd say put it in there, make sure the air comes out that side. You can feel it?
It's right here.
Yep, okay, so it's not blocked. Oh, you'll have to turn it because we're not using this anymore, we're using that. And just line up the holes. There. Yeah, it should be centered.
It's about
Is it centered? I can hold it.
I think I'll have to move the jar a little bit. The rings move.
Yeah, it should be good. That's just for safety. Press on here the run button. It's the blue guy. Yes, what is she saying? Okay, confirm the settings, touch her. Did you close the cover? Yes, you did. Is the water fixed quantity? Yes, it is. Did you set the hydrogas filter? Yes. And mode selection, click on mode selection. And say commence. All right. So it's heating. And we just wait until we see that it's driven off any possible water, and then we can walk away and come back in 3 hours. So now, of course, because the bottom is over 212, it's all climbing up here very hot, and it's starting to pyrolyze. At 212, if that's stalled, that would mean there's water vapor that's, or water that's not turned completely into vapor, and that could create a problem. But now we're safely over it, so we can leave this for the next 3 hours and let that plastic turn into oil.